Hello, Keith Rucker here at VintageMachinery.org. Guys, today we got a little project that we're going to be getting started on. This is a new project coming in the shop that doing for a viewer out there, helping out on a project that he's got. And what this is a gear that we've got some missing teeth on that we're needing to remake. And this particular gear came off of a model steam traction engine. I believe he told me it was a scale model of a case traction engine. This is for a group up in Cumming, Georgia that has a big fair, big festival every year. They run these engines multiple times a year. And they had a mishap with this particular one, and in the process messed the teeth up on this bull gear that drives the whole wheels on the traction engine. Asked if I could make them a new one. So this one is going to be make a new gear from scratch. We're not even going to try to do a repair job on it. It's just too much torque on these teeth. We're missing 3 teeth together in a row over here, 2 teeth right here, 1 tooth over here. So we got multiple places it's missing teeth on, and we're just gonna make a new gear on this thing. So I'll show you up close here in a minute. This is actually a two-part gear. We got a spur gear on this end and a bevel gear on the other end. And it is a 2-piece gear. This is actually 2 different gears that are pressed and keyed and pinned together. We're not going to remake the bevel gear. We're going to just continue using what they've got here because it's fine as it is. We're just going to make this part down here. We're making this out of cast iron. That's what the original gear was made out of, and decided to go back with keeping it with the original materials that it was made. So anyway, I have got a piece of Durabar here. This is just basically a piece of extruded cast iron that we will be making the part from. And we're going to be starting out over on the lathe. So today's job is I want to get the gear blank made. Once that's done, we'll go over to the horizontal milling machine and we'll actually cut the teeth in here. I do have a cutter for this, but I had to send it off and get it sharpened. I don't have the cutter back yet, but I am expecting that back soon. So hopefully we'll be able to get the teeth cut on the gear. But before we do that, we do have to make the gear blank. So let me zoom in here, kind of show you what we got to work with, and we'll get busy and see if we can get this thing knocked out. So again, 2-piece gear. This is pressed together. You can see this has the little flange that presses down in there. That is a press fit. There's a key here that fits this key, and there's also 2 pins that kind of drive all this together. I was able to press this apart over on my arbor press, and I had already done that little part of the job. So I'm just trying to get down to the part that we need to make, which is this part right here. And you can see, again, 1 tooth missing here, 2 teeth missing here, 3 teeth missing here, and you can tell where it had been brazed and repaired previously in the past. This tooth has got brazed material added in, and they went and recut that tooth. And I can see the remains of some brazed material up here, so I'm assuming that this tooth also had been brazed back together at some point in time. The rest of the teeth appear to be original. So again, right now what I want to do is just kind of rough this out. So I got a piece of Durabar. We're going to be going over to the lathe. I'm going to start out by just cutting it to length. We'll go over to the lathe and we'll start machining this thing out to get it to the sizes that we need to then go to the horizontal milling machine. Now I will note that I need to measure this size here. This is the size for the through hole in this, and originally this hole was the same size as this. I put it in the lathe and I bored this out just so that I could get a piece in there, and I basically was able to get down on this shoulder and press this apart. It wasn't coming apart easily, so I did that, but I know that it's the same diameter as this one, so that will be an adjustment I'll need to make, but no big deal. All right, again, here's my piece of stock we're going to make it out of. This again is just a piece of Durabar, a little over 5 inches in diameter. Just ordered it from McMaster-Carr. I'm going to go saw this off. We only need about half of that thickness or length of this bar to make this from. So I'm going to go to the bandsaw. We'll get that cut in half, and then we'll meet you over at the lathe and start seeing if we can get this thing turned out. So I got to thinking about my workflow and how I want to do this, and I decided to bring this over to the lathe before I cut it to length and go ahead and do a couple of things. First, I want to face this side here, and then I also want to true up the outside of this just enough to clean up. Now, my part needs to be 5 inches in diameter, and we're about 5 1/8 inch on the nominal size here, so I'm not going to take it down to the 5 inches, but I do want to just get a area turned down on this that is square to the face and that is round, perfectly round, not this extruded size, so that we can chuck up on it and have it fairly running somewhat true as we're working on the other side of it. So anyway, that's kind of the game plan. I need to figure out how thick this needs to be and turn down that side, but we'll start by facing this. So I just got it in a 3-jaw chuck. And we're just going to touch off here. And face that off. All right, I think that cleaned up good. It did. It looks like the part that we're going to make is a little less than 3 inches in length. So we're just going to come in here, and I'd already zeroed that on my digital readout. It's not quite cleaning up. I'm going to turn that down 3 inches. That's 3 inches. Yeah, we got a good bit to take out of there still, so. All right, that is more or less cleaned up. Just barely cleaned up in a couple places, but that'll be good. And we've still got a good 75, 80 thousandths on the diameter to take off, which is what I wanted to be. All right, I'm gonna break that corner just so we don't cut ourselves on it. It's plenty. And I'm gonna go basically just saw this off to that length right there, and we'll come flip it back around and start working on the other side. Over at the marble saw, I got this in here ready to saw, and we'll let it just take its time and cut across. There we go. We've got our part chucked back over on the lathe now. We're on the outside diameter, so that should be running fairly true. You know, we're going to turn this outside once we get a center hole punched through it, so it's just close right now. We also got it all the way up against the chuck. I came in and touched off on the chuck, and that should give me a length here on this part, which needs to be, according to matching the original, 2.937 is what that is. I imagine that tolerance is not probably that critical, but we're gonna dial it right in there, and I can just use the digital readout for that. So we're gonna start by facing this to length. We'll just come in here and start facing across. That saw cut was not perfectly straight, which is fine. I have plenty of material on there to face off, kind of anticipating that. So we'll get this trued up and we'll get it to length. Again, 2.937. Right now I'm at 3.033. So about what, about 40, a little over 40 thousandths to take off the length to get it to where it needs to be. I'm dialing in my 937 here, and we're just going to go ahead and face this to the final length. This should be my final pass. All right, that should be to length. Now I need to cut a step in this. The diameter needs to be 3.721. It needs to go in 687 thousandths. Again, working off the original. So what I'm going to do is using the digital readout here. Hope I got enough room to do this. Is that 687? Make sure that's going to clear. Whoa, barely. That'll be fine though. That's how far we need to go. That's perfect. Barely got clearance there. I'm just going to make a mark here on the casting where I can kind of have a visual where I'm going to turn that to. And we're going to start turning that step in there. I'm taking a 200 thousandths cut. Got a good bit of material to remove, so I'm just going to try to get this knocked out. Okay, so we're at 755. And we need to go to 721. I'm just going to dial that in. And this measurement isn't super critical. So we're just going to roll with it. 721. And my depth is 687. And we should have that step pretty well cut. I'm going to break some corners and we'll be ready to start boring the hole through there. Let me get this screen out of my way. And we should have that step pretty well cut. I'm going to break some corners and we'll be ready to start boring the hole through there. Let me get this screen out of my way. Break that corner, and I think I can reach in here and get this one as well. That's plenty. All right, next step, we need to bore our hole in here. So we're gonna get a hole all the way through here, 1 11/16, and there's gonna be a counter bore on this side, and we'll take care of that in a little bit. So start by getting a hole drilled through there, and then I'll probably bore it to the final size, and then we'll put the counter bore in. And we'll start by putting a center in here. The center will find, it's going to kind of wobble around a little bit there, but it will find the exact center of that piece. I just want to put a little dimple there. And we'll come in here with a drill bit, and we're just going to start by getting a hole drilled all the way through this. All right, we are through, and go up to another drill bit here. We're going up to a 1-inch hole here. I did slow my speed down to about 350 RPM, which is close to what's rated for drilling a 1-inch hole in cast iron. All right, I've got a 1 9/16, which was the closest I had to that size in a number 4 Morse taper, which is what fits this lathe. I had some bigger ones in a number 5 Morse taper, which will fit on the radial drill. Also slowed my lathe down a little bit. We'll go ahead and get this drilled through. Plan B, gone to an 1.5-inch drill bit. That one, 9/16 was too dull. It wasn't cutting. This one appears to be doing a little bit better. All right, that got through there that time. All right, we got a boring bar set up here. I'm gonna come into a hole, touch off. I'm gonna start by just making a fairly light pass through there, just to kind of get a good measurement. Let's go right there. Going to use a bore mic here to get a measurement. 89, so 1.589 is where we're at right now. I'll put that in the digital readout. 1.589, and we're going to 11/16, which is 6.875. So I went over and remeasured my other hole, and it was just a little bit oversized, probably from where I've got this within about a 1/2 thou. It's about a 1/2 thou smaller than the hole in the other piece that this has to kind of line up with. And again, I think we probably got some wear in there. So this is, I think we're fine. We're going to cut it right there. We're about 1.5 thou over the measurement. Again, this is going to be up on a shaft. It's going to have to slide on. So that's probably good clearance. I think we're where we need to be. So next, we need to worry about get this counter bore in there. And we'll work on that here coming up. So next up, we got our counter bore, and that needs to be 2.187. This is going to be a very precise diameter. This is going to have that other gear is going to press down inside that. It is a press fit with about a 1/1000th interference. So the part that's going in there is about 1/1000th larger than the hole that we're going to bore in there. So this is a critical measurement. Depth on it is 1.150. What I'm going to do is I'm just going to touch my cutter off here. I'm going to zero in my Z-axis on the digital readout, and then I'm going to take this in 1.150. I went too far. 1.134 right there, and I'm going to zero my digital readout, that is my target. That is where I'm going to. So basically I can watch as I'm boring, and when I get to 0 on the digital readout, that's where I need to stop and I'll be at depth. This depth is not a critical measurement. Basically, it just gives me clearance. That piece, the bore is a little bit deeper than the piece is going to press in there, but we need to have clearance down there in the bottom. All right, I think we are ready to go. Again, we're going to 2.187, and we're starting out at 1.8675 roughly. Just going to watch my digital readout as I'm boring and stop down there at 0 on the depth. Got about 50 thousandths to go. And just taking the last little bit in by hand. There we go. All right, that's 75, 80. We're about 284. We're going to 287. So I'm going to do another spring pass here and just see where we clean up at. Just barely fuzzing there. And I think we're right where we need to be. Yep. All right, that should be a good fit right there. I'm just going to take my little Noga handy burring tool and we'll deburr the inside of that corner there. So we've got the turning on this end done. Really, all that's left to do from a turning standpoint on this is the outside diameter. And I want to do that on a mandrel. So a mandrel will basically, we're going to need to have it on a mandrel to cut the gear teeth, and I really want it running perfectly true with this center hub. So I'm going to turn a mandrel to mount this on, and then we'll get that outside diameter cut, and I think we'll have this knocked out. Ready for gear teeth. So now I need to make this mandrel to mount this on to actually turn the outside diameter as well as to cut the teeth over on the dividing head. So we're just making basically a spindle this is going to sit on and tighten up on that will hold it, that we can actually hold it from a shaft. So I've kind of got a sketch here of what I want to do. We're just going to basically have a shoulder here on the back. The gear will fit up on this stub here, and then I'm going to have a threaded area down here that we can just tighten the nut up on. We'll put centers in both ends so that we can turn it between centers, or put a center support on it while we're over on the dividing head. So anyway, let's get her going here. Facing this and putting a center hole in it. We're going to put a center in there to put support on that. Go. Tailstock in, and we'll put a live center in there to support it while we're turning this. And I'll come in here and just barely touch off on this end. Zero out my digital readout. I need to turn in 3 inches, which is right there. I'm just going to put a mark. Give me a visual to when I'm turning that down, and this gets turned down to 1.8675, 1 11/16. think I said the wrong measurement a while ago. We're going to 1.6875. So we got a good bit more to take off of here. Let's go ahead and finish cutting that out. Yeah. Perfect. I'm going to change cutters because I need to kind of reach in here, and that other one would hit my live center. See how that cuts. We need to go down to 1 inch on this. We're just going to thread this, or put threads on it rather. Go into that shoulder, and then I'm going to face out to square that up. I'm going to come in here. I want to face this shoulder out as well. Wrist nice and square. Okay. And now, tell you what, while I'm here, I want to just turn this just enough to clean it up. Clean up. Got a little skip in it. All right, we are setting up for single point threading. First thing I'm going to do is just put a little chamfer at the thread angle here on the end, so we have a nice lead-in area there. I'll chamfer that pretty deep. Touch off, and we're going to single point thread this. A little cutting oil on here. One more in a spring pass, I'll probably get it. We'll do a test fit here in just a second. Doing 5,000 steps on these final passes here. I got a nice sharp point at the top, which is usually an indication that we're about to depth. And I'm going to just, I'm not even going to feed in this pass. This is just going to be a cleanup pass. Like I said, just a spring pass. Just let my number come around the dial. And that should be good, but we'll check it. It's a little on the tight side, but it's fine. Put our part up on the mandrel. Got our washer up on there. This nut will tighten up and kind of sandwich it all in there together and give us something that we can turn this on. So. All right, let me get that tightened up and we can turn this outside diameter and we'll have this part finished up. All right, we need to take this to 5 inches. And we are at basically 102 thousandths over. So we got 100 thousandths to take off of it. we got our diameter done. I'm going to chamfer these inside and outside edges. And our gear blank is made. We are ready to cut teeth. All right, guys, I think we have got our work done for today. So I have the gear blank is machined. It is ready to cut the teeth on, but I'm not ready to cut the teeth because I got to get my cutter back that I sent off to get sharpened, the involute cutter. So, but we are ready to go over to the horizontal mill when that gets here. I've got my arbor ready. I did off camera turn the back side of this and put a little step on there. This will go up in the dividing head. That'll give it a shoulder so that as it's cutting, it'll be pushing against the shoulder on the chuck on the dividing head. So there's no way that this can move inside that chuck. And to do that, I didn't do it on camera, but I just turned this part around, put it in the forward jaw chuck. We indicated until we got the part down here turning true, and then I just cleaned everything up and cut that step on there. So that is all ready to go. So, you know, we got our threads there. This just is going to fit right back up on this arbor. Like arbor will go on the gear like that, and then that's ready to go onto the dividing head to cut the teeth. And we'll be doing that in an upcoming video. And once that's done, we'll have to remount the bevel gear on the end here, press that in, pin it. I got to cut a key in here for this key, but that'll all come after we get the teeth cut. So we got that knocked out. Well, there we go. Some lathe work today, cutting a gear blank for a steam engine, traction engine gear. And hopefully, once we get this involute cutter back in the shop, we can get those gear teeth cut out and get this back to their customer where they can get their engine back up and running. They were in a bit of a rush to get this done, so you know, we're trying to get them accommodated so they can use this. They were wanting to have it ready for the 4th of July if they had a show going then, and there was just no way I could get it done with going to the Bar Z Bash and then having my little shop open house last weekend. So I did want to go ahead and get this knocked out because they do have another event coming up here, I think in late August something, and they needed time to be able to get this thing back put together and running. So anyway, we should hopefully have them back up and going here pretty quickly once we get that cutter back in the shop. Guys, with that, hope you enjoyed that. We will be finishing this up, and that's going to be a wrap on this video. So with that, we're going to sign off. As always, thanks for watching. Please subscribe to the channel if you haven't already. Thumbs up and comments are always greatly appreciated. Hit that bell icon up there to get notifications when new videos are posted. And as always, a big, huge thank you to all the supporters of the site who support financially through PayPal and Patreon, which allows me to take the time to shoot video to share with you guys. So hopefully got something out of this, and hopefully we'll see you again soon. So with that, we'll sign off. We'll catch you later. Thanks.